Section 1.4 of our textbook reviews how we simplify rational expressions, specifically when we're multiplying and dividing them, and specifically dividing complex fractions. So let's first start with how we can reduce rational expressions simply by dividing out factors. I want to notice that we divide out factors, things that are multiplied. We will never cancel terms, things that are added together. If things are added together, we cannot reduce the fractions. We can only divide things that are multiplied together. So if we have something like x squared plus x minus 90 over x squared plus 13x plus 30, and it's multiplied by x squared minus 9 over x squared minus 81, we cannot do any reducing because of all that adding and subtracting in there until we first factor everything. So let's factor that first fraction, that numerator. X squared is going to be x times x, and 90 is 9 times 10. If the 10's positive and the 9's negative, we get positive 1 in the middle. In the denominator, we've got x times x to be x squared. And 30 is going to come from 10 and 13. I'm sorry, 10 and 3, with both of them being positive. Then we have a times. X squared minus 9, that's a difference of squares. That's x plus 3, x minus 3. And the denominator, x squared minus 81, that's also a difference of squares. X plus 9, x minus 9. And now that it's factored, now we can divide out factors that appear both in the numerator and denominator. The x minus 9 goes out with the x minus 9. The x plus 10 goes out with the x plus 10. The x plus 3 goes out with the x plus 3. And all that we have left in the numerator is an x minus 3. And in the denominator, an x plus 9 for our simplified expression. When we are multiplying, we can just start reducing out common factors. When we're dividing, there's one extra step we're going to take. So let's take a look at that with 3x squared minus 4x minus 15 over 3x squared minus 14x plus 15 divided by 3x squared minus x minus 10 over x squared minus 4. Because this problem is dividing, we recall that with fractions, the way we divide with fractions is we multiply by the reciprocal. So as we factor, we're going to flip this fraction upside down. First, though, the first fraction, let's factor it. In the numerator, 3x squared is 3x times x. 15 is 5 times 3, and the 3 is not going to be with the other 3. And if the 3 times 3, 9 is negative, plus 5 will give us the 4x in the middle. All over the second denominator, 3x times x is 3x squared. Again, 15 is 5 times 3. And we can't put the 3 with the 3 because they would have a GCF then. And if they're both negative, we would have negative 14. Now with the second fraction, we're multiplying by the reciprocal. So now the denominator x squared minus 4 is going to move on top as we factor it. So x squared minus 4 is x plus 2, x minus 2, a difference of squares. And then the denominator is what used to be in the numerator, 3x squared minus x minus 10. We've got 3x times x. And the 10 is 5 times 2. And if we check that, we've got 6 and 5. If the 6 is negative and the 5 is positive, it would give us that negative x in the middle. So now with our fraction, we can divide out the common factors. The x minus 3's are gone. The 3x plus 5's are gone. And the x minus 2's are gone in this problem. Which means left behind in the numerator is just the x plus 2 factor. and in the denominator, the 3x minus 5 factor. And we have our solution. Let's do one more that's just a little bit more involved, but really the same idea extended out to the next level. If we have x to the 2n minus 3x to the n minus 4 over 16x to the 2n minus 9 times 4x to the 2n minus x to the n minus 3 over 2x to the 2n minus 13x to the n plus 20 divided by x to the 2n minus 1 all over 4x to the 2n minus 20x to the n plus 25. Multiplying and dividing in this problem, but really much the same problem. The division means we're going to have to multiply by the reciprocal. We're going to flip that fraction over as we factor it. But first let's factor the first fraction. X to the 2n is x to the n times x to the n. And 4 is 4 times 1 if the 4 is negative and the 1 is positive. Over the denominator is a difference of squares because we've got that even exponent. So it's 4x to the n plus 3, 4x to the n minus 3 times the second fraction, 4x to the 2n. That could be either 4 times 1 or 2 times 2. Let's try 2 times 2 first. 2x to the n times 2x to the n. And 3 is 3 times 1. So that'll give us 2 and 6 as we multiply the outside and inside. And 2 and 6 are not going to give us the 1 in the middle that we want. Switching the 3 and 1 won't make a difference because the 2's are the same on both sides. So instead of 2 times 2, let's try 4 times 4. We're just kind of doing a guess and check here. 4x to the n and 4 times 1, sorry. It's another way to get 4x squared, or 4x to the 2n. So on the outside we have 4. On the inside we have 3. If it's minus 4 plus 3, that would give us the negative 1. We've got our solution. If that didn't work, we could have switched to 3 and 1 and see if that would have helped, but we got it this time. So in the denominator now, 2x to the n times x to the n is 2x to the 2n. Lots of ways to get the 20. One might be 4 and 5. We don't want to put the 4 with the 2, so 4 and 5. Let's see what that gives us. 8 and 5, if they're both negative, would be negative 13. So that's good. For our last fraction, we're going to change it to multiplying by the reciprocal. So the reciprocal in the numerator, we're going to put what was in the denominator. 4x to the 2n, it could be 2x to the n times 2x to the n. 25 could be 5 times 5. And if they're both negative, we get negative 10, and negative 10 is negative 20. So we got that. Over, the numerator is a difference of 2 squareds, x to the n plus 1 and x to the n minus 1. So the only real difference is there's just a lot of factoring in this problem. But now it's much the same. We do our reducing. There's an x to the n plus 1. Whoops. Let me back up. X to the n plus 1. Make sure I grab the right one. There we go. There's a 4x to the n plus 3. There's a 2x to the n minus 5. There's an x to the n minus 4. There's an x to the n minus 1. And so when we do all of our reducing, this one turns out all that's left is 2x to the n minus 5 over 4x to the n minus 3. And we have our solution. So multiplying and dividing fractions, not too bad. Factor it and divide out your common factors, but never, ever, never cancel terms. Always divide out factors. Factors are multiplied, terms are added. What's going to be more interesting to us as we work through these problems, though, are these things called complex fractions. And a complex fraction, also called a compound fraction, is when we have fractions in fractions. And this becomes a little bit of a headache to deal with. The easiest way I have found to deal with these complex fractions is we're going to multiply each term, top and bottom, numerator and denominator, by the least common denominator. Here's what I mean by that. If we have 3 over x squared plus 1 over x all over x minus 9 over x. As I look at my little fractions, there's an x squared, an x, and an x, and don't forget technically this last one is over 1, so it also has a denominator. The common denominator there, if we take the highest exponent, is x squared. And so what I'm going to do is I'm going to multiply each term, top and bottom, by the x squared. Because when I do that, x squared will go out with x squared. A single x goes out with a single x, leaving behind one x. In the denominator, again, a single x goes out with a single x, and so what's going to be left is 3 plus x, 1 times x is x, over x squared times x is x cubed, minus 9x. And now we can look at simplifying this. The denominator is a GCF of x. When we factor that out, we have x squared minus 9 under the 3 plus x. But x squared minus 9 is still a difference of squares, so it's x plus 3, x minus 3. And what you notice is the x plus 3's are going to divide out, leaving behind our solution. Notice everything divides out of the numerator. Anything divided by itself is 1, so we still need a 1 in the numerator, over x times x minus 3. And this is considered our simplified complex fraction, multiplying each term by the least common denominator. So let's try another one. Let's do x over x minus y minus 1 all over x plus y minus 1. Here we've got a denominator of x minus y and a denominator of x plus y. We treat those like factors. We are going to multiply everything by x plus y, x minus y. Don't forget to also multiply the 1's by x plus y, x minus y, x plus y, x minus y. And when we do, the x minus y's divide out, and the x plus y's are going to divide out, because I also should have multiplied it by this term. And what is left is an x times x plus y minus x plus y times x minus y, all over an x times x minus y minus an x plus y, x minus y. Distributing through, we have x squared plus xy minus, this is a sum and a difference, so we've got x times x is x squared, y times y is negative y squared, but be careful, we're subtracting negative y squared, which makes it plus y squared. All over, distributing the x through, we have x squared minus xy. And again, x times x is negative x squared. Y times negative y, subtracting it, makes it plus y squared. So the only simplifying we can do is x squared minus x squared in both top and bottom. And that gives us xy plus y squared over negative xy plus y squared. Well, we can keep simplifying that. Factor out a GCF of y, leaves behind x plus y. Over, factor out a GCF of y, leaves behind negative x plus y. The y's are gone. And so for our final answer, x plus y over, I'm going to move it to y minus x. You could say negative x plus y, but I just think that's prettier. And we have our solution. A little bit of algebra to get there, but nothing too bad. Clear the compound fraction by multiplying by the LCD. Let's try one more example like this. Let's do a over 2 plus a plus 2 minus a over a all over a over 2 plus a minus 2 minus a over a. Again, the 2 plus a, since those are terms, we have to treat those as one big factor, so we've got 2 plus a and a. 2 plus a and a. Our GCF is a times 2 plus a. 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 Multiplying every term, so the 2 plus a's can divide out, the a's can divide out, the 2 plus a's divide out, and the a's divide out. As we do, we want to be careful to keep the numerators of 2 minus a together as a group. We weren't just multiplying the a, we were multiplying the entire thing. So we have a times a, or a squared, plus 2 minus a times 2 plus a, all over a times a is a squared, minus 2 minus a times 2 plus a. Foiling out in the numerator, notice again that's a difference of squares. That's going to save us some work on the FOIL. 2 times 2 is 4, negative a times a is negative a squared. The middle terms are going to subtract out to 0. Over a squared minus 2 times 2 is 4. And again, we're going to have minus a negative is a positive, a squared. And this is nice because the a squared subtract out to 0. A squared plus a squared is 2a squared, so we have 4 over 2a squared minus 4. But don't stop there, because there's a GCF we can factor out of the denominator of 2 times a squared minus 2. And then we can reduce 4 over 2 is 2. So for our final answer, we have 2 over a squared minus 2. Compound fractions. Multiply by the common denominator every term. Then multiply it out and simplify. Now another type of compound fraction is one that involves negative exponents. And really these negative exponents aren't any type of new problem. They're exactly like the compound fractions we just saw. The only difference is this one extra step that every term becomes a small fraction. What you need to remember, though, is we only move the part, or the factor, with a negative exponent. So let's look at some of these examples. Let's say we've got a to the negative 3b minus ab to the negative 3 all over a to the negative 2 minus b to the negative 2. Negative exponents. Well, each negative exponent is going to make that little piece move to the denominator of a little fraction. But as we do, notice we're only going to move the factor with a negative exponent. So the b stays on top and the a cubed moves down. Minus the a stays on top and now the b cubed moves down. All over, when the a squared moves down, we need a placeholder of 1 on top. Minus when the b squared moves down, we need a placeholder of 1 on top. So the negative exponent simply signifies to us that we need to move down to the denominator of a little fraction. The common error I see people do is they just move things up and down on the single fraction without making these little fractions, this complex fraction. We can only move across a fraction bar if it's all multiplying. Just like we couldn't reduce when there was adding and subtracting, we can't move things around when there's adding and subtracting. So we just make these little fractions instead and solve it as a compound fraction. In the denominators, we've got a cubed and a squared, b cubed and b squared. The common denominator then is a cubed, b cubed. Always taking the highest exponent on each factor. So we'll multiply each term by a cubed, b cubed, a cubed, b cubed. And when we do, the a cubed goes out with the a cubed. The b cubed goes out with the b cubed. A squared leaves 1a behind, b squared leaves 1b behind, and so we have b to the 4th minus a to the 4th all over ab cubed minus a cubed b. Now that we've gotten rid of the compound fraction part of things, that negative exponent, we're going to factor this and see if we can simplify. The numerator is a difference of squares, because those are both even exponents. It's b squared plus a squared times b squared minus a squared. The denominator has a GCF of ab. When we factor out ab, we're left with b squared minus a squared, which is kind of nice. We could factor the difference of squares more, but those b squared minus a squareds are just going to divide out right now, leaving behind our final answer of b squared plus a squared over ab. Let's try another one that has negative exponents. Let's do a to the negative 2 plus a to the negative 1 minus 2 all over a to the negative 1 minus 1. Again, because of all that adding and subtracting, we can't just move the a's around. We have to make little fractions. A to the negative 2 becomes 1 over a squared, plus a to the negative 1 becomes 1 over a minus 2. All over a to the negative 1 becomes 1 over a minus 1. Now with a compound fraction, we look at the denominators to find the least common denominator is a squared. And so we'll start multiplying every term by a squared. Reducing, the a squareds are gone. A leaves behind 1a. A leaves behind 1a. And so now the problem is 1 plus 1a minus 2a squared all over a minus a squared. Now that we've gotten rid of the compound fraction bit of things, we can look at how we can simplify this expression by factoring. 1 is 1 times 1, and 2a squared is 2a times a. To get a positive a in the middle, we want the 2 to be positive on the middle and the negative on the outside. All over. We've got a GCF of a. Factor that out. We're left with a divided by a is 1 minus a. And sure enough, those 1 minus a's will divide out, leaving behind our final answer of 1 plus 2a over a. Completely simplified. Let's do one last problem before we wrap up here. Let's do a plus 1 to the negative 2 minus 1 over a plus 1 to the negative 2 plus 1. Again, with the adding and subtracting between terms, we cannot just move things around. We also cannot do any reducing. We need to first make little fractions. Using 1 as a placeholder, the a plus 1 to the negative 2 moves to the bottom to a plus 1 squared minus 1 all over 1 over a plus 1 squared plus 1. The only denominator we have to work with is the a plus 1 squared. So we'll multiply by a plus 1 squared, a plus 1 squared, a plus 1 squared, and a plus 1 squared. Again, notice we also multiplied the 1's. The a plus 1 squareds divide out quite nicely, leaving behind 1 minus a plus 1 squared all over 1 plus a plus 1 squared. Be careful of that negative when we distribute it through. It's going to change sign. So we have 1 minus a squared. 1 times a is a, 1 times a is a, so that's 2a. Don't forget to distribute the negative. And 1 squared is 1. Distribute the negative again. All over 1. This time we're distributing a plus. That's going to keep everything positive. A squared plus 2a plus 1. Combine like terms. The 1 minus 1 is 0, so we have negative a squared minus 2a over a squared plus 2a plus 2. And I guess technically in the numerator we can factor out a negative a, leaves behind a plus 2. But that denominator is not going to factor at all, so this time we're not going to get any reducing. So either one of these two answers would be just fine for our final solution. So that's what we're taking a look at on today's assignment, section 1.4, simplifying rational expressions. We can factor and reduce when multiplying. To divide, we multiply by the reciprocal. With complex fractions, we multiply each term by the LCD. And with negative exponents, we make little fractions, turning it into a complex fraction. Take a look at the homework. Let me know if you have any questions.